Atomic radius. Atomic radius is generally stated as being the total distance from an atom's nucleus to the outermost orbital of electron. In simpler terms, it can be defined as something similar to the radius of a circle, where the center of the circle is the nucleus and the outer edge of the circle is the outermost orbital of electron. As you begin to move across or down the periodic table, trends emerge that help explain how atomic radii change. The effective nuclear charge of an atom is the net positive charge felt by the valence electrons. Some positive charge is shielded by the core electrons, therefore the total positive charge is not felt by the valence electrons. Effective nuclear charge greatly affects the atomic size of an atom. So as the effective nuclear charge decreases, the atomic radius will grow as a result because there is more screening of the electrons from the nucleus, which decreases the attraction between the nucleus and the electrons. Since effective nuclear charge decreases going down a group and right to left across the periodic table, the atomic radius will increase going down a group and right to left across the periodic table. Types of radius with respect to types of bonds. Determining the atomic radii is rather difficult because there is an uncertainty in the position of the outermost electron. We do not know exactly where the electron is. This phenomenon can be explained by the Heisenberg uncertainty principle. To get a precise measurement of the radius, but still not an entirely correct measurement, we determine the radius based on the distance between the nuclei of two bonded atoms. The radii of atoms are therefore determined by the bonds they form. An atom will have different radii depending on the bond it forms, so there is no fixed radius of an atom. Covalent radius. When a covalent bond is present between two atoms, the covalent radius can be determined. When two atoms of the same element are covalently bonded, the radius of each atom will be half the distance between the two nuclei because they equally attract the electrons. The distance between two nuclei will give the diameter of an atom, but you want the radius which is half the diameter. Covalent radii will increase in the same pattern as atomic radii. The reason for this trend is that the bigger the radii, the farther the distance between the two nuclei. Ionic radius. The ionic radius is the radius of an atom forming ionic bond or an ion. The radius of each atom in an ionic bond will be different than that in a covalent bond. This is an important concept. The reason for the variability in radius is due to the fact that the atoms in an ionic bond are of greatly different size. One of the atoms is positively charged, which is smaller in size, and the other atom is negatively charged, which is a lot larger in size. So in order to account for this difference, one must get the total distance between the two nuclei and divide the distance according to atomic size. The bigger the atomic size, the larger radius it will have. Metallic radius. The metallic radius is the radius of an atom joined by a metallic bond. The metallic radius is half of the total distance between the nuclei of two adjacent atoms in a metallic cluster. Since a metal will be a group of atoms of the same element, the distance of each atom will be the same. Periodic trends of atomic radius. An atom gets larger as the number of electronic shells increase, therefore the radius of atoms increases as you go down a certain group in the periodic table of elements. In general, the size of an atom will decrease as you move from left to the right of a certain period. Exceptions. Because the electrons added in the transition elements are added in the inner electron shell. At the same time, the outer shell remains constant, the nucleus attracts the electrons inward. The electron configuration of the transition metals explains this phenomenon.